Oops. A lot of beeping. I'm not really sure what happened, but I think we are on time. And I just realized I was pushing the wrong button. I should have pushed go live instead of start recording. Anyway, the subject of today is this guy here. So this is called the KWS-306L, and as you can see, it has like, you know, a couple of inputs and outputs, and because it has 4, maybe you can guess that this is a 3-phase electricity meter. And it actually, well, this is an RS-485 port, so I'm going to use this converter to actually hook it up with my laptop, and we are going to see how it works on Modbus, because I got some documentation for this, and I want to test it out. And the reason I want to test this because this comes from a company called KWS. I'm not really sure how to pronounce their website. Sometimes the website works, sometimes it doesn't. And also on AliExpress, it is being manufactured. It is being distributed by, you know, zillions of different sellers. So I'm just going to pick a listing for you, one which I think actually my father-in-law used to purchase this, because he purchased this and said, "Oh, this is really cool device. You should try it out." And as you can see, the you know, it ranges from, let's say if I pick this listing, then 23, 26, 27. Literally, when I was looking this a couple of weeks ago, it was more like 21 and that sort of stuff. And it comes in 3 different versions. So there is the 306 version, which works with Tuya. So it has Wi-Fi. My laptop is beeping. It's like USB is disconnecting. Anyway, and there is this version that I have, which has Modbus. So you see RS-485. And there is a version which doesn't have any output. So it's just a screen. It does all the functions. You can use the buttons to configure it. And the reason we said that this is really important, well, this is quite useful, because it has a tons of built-in protection, like over voltage, under voltage, everything. And then it also has a built-in contactor. So actually it can act on those conditions. So you can configure it so it, you know, cuts the power if the power consumption goes above, or the wattage, or over voltage, under voltage, also temperature, and then it's just going to cut the load. So that's quite interesting. So I want to see how it works in Modbus, what we can get out of it, and how we can also control it, because apparently you can control it. So the only other thing I got this, you know, the AliExpress out, because as I said, it's being sold by, you see how many different stores. So it looks like the price ranges from a low 20s to like the high 30s for the different models. And all of them are like, you know, basically just bigger distributors. So it took me a while to get the documentation, especially the Modbus documentation, because they all had like a standard documentation and nothing else. And as you see, the KWS website, you know, 2 weeks ago I was managed to load this. Now it's just not responding. Yeah, I don't have authorization. Like, you know, what do you need? And there was nothing on the website, like in terms of, you know, supporting documents or download or anything like that. So it wasn't really useful. So it took me a couple of, I don't know, like a week until I just emailed like, I don't know, half a dozen of sellers, like asking for documentation, and they all sent me the wrong documentation. But eventually I got one which seems to be working. It was full Chinese, so I just translated it in Google. Actually next up. So let's see how this works. So first of all, it comes in this rather unassuming box. There is no documentation whatsoever provided. Yeah, this is completely empty. There wasn't nothing in it either. So we are definitely relying on what we got out of the internet. So what I'm going to do is I'm going to hook this up to USB, and I'm going to plug, as you can see, I just have like a simple pigtail. You have in the inputs on the top, so the three phases ABC and neutral, and I just you know, hook the same phase through all the inputs, and on the outputs we have like 3 sockets wired in. So I managed to find some lamps and fans and what else, a power station that we can use as a you know, a load. So I'm just going to plug this in. Okay, yeah, so now we can see the screen, and I think I'm just going to move a little bit closer, so just one sec. Yeah, like that. The thing is that it has this screen, which is actually quite nice. This is like an LED screen, and so it has blue, red, and green in the 3 columns, and it has 3 lines for the, you know, the 3 different phases. And actually the red looks really good for the naked eye, but for some reason this camera is not really picking up. So you have voltage on the left, and then amps, and then kilowatts on the right. And I think just being going to look at the documentation, so you can do power factor, and then you can do the kilowatts here, and then you can, you know, look at based on, oh, you have loads of different screens here, so you can look at the kilowatts for each of the phases, and then the sum, and I guess that's total kilowatt across the 3 phases. And you also have time, so it also can count how long the output was on, and that's the contactor. And by the way, it is rated for 83 amps. So now it's on. What's in the memory? I guess nothing really. Okay, so that's the basic operation of the device. You see it's 4 DIN rail size. So before we go, let me just change the view. I just want to show you some of the documentation. So I have a PDF user manual. Which, you know, it talks through, well, not 83 amps, but 80 amps. So it talks through the 3 different variants. And then you can see, you know, timings, and I mean, most of them are the same. All the protection is supported for all of them. And then, you know, like this cycle timing is only supported in the Tuya version. And again, some of the app related stuff are not supported in the 3rd version, which doesn't have any app you know, connections like Wi-Fi or RS485. Okay, for the Wi-Fi version, yeah, you can do this, and then yeah, we have seen the phases, sum total energy, power, and timing. Okay, so it says press and hold the M button for 3 seconds to get into the setup page by entering the setup and button. Okay, 0, 1, and then plus minus. Okay, so that's the overvoltage setting. Overvoltage setting is you know, 0, 1, and then you can do undervoltage setting, and oh, pressing the N button where you get the screen where you need. Okay. Over current setting, that's figure 3. So that's code 3. I mean, the reason this is important, because again, if you buy the 3rd variant, which doesn't have Wi-Fi or RS485, then you only have the screen to do all these settings. Just one sec. Let me just... Okay, nothing, that's all. Oops. And what else? So 04 is the over power settings, and then access energy. So you can also set it to 05. So once it goes above 1/3 kilowatt hours, then you can do that. And then timing. So you can also do it on time. That's good. I mean, it doesn't really say what the time is, but I'm assuming that, you know, once there is anything on the output, then the timer starts up. Yeah, because the time is still showing 0, 0, 0, even though it's powered up for some time now. And so that's 7, and then you can do voltage imbalance as well. So if there is a voltage difference of 1 volt across the 3 phases, then you can do that as well. And then current imbalance. So again, these are you know, good options for, you know, specific loads, and screensaver timeout and timer reset. And then power reset. Okay, that just basically zeroes out the sum value. And then factor reset. Oh, and then you can see the default values here. Okay, so let's look at this, how this looks like. So yeah, and I can cycle through the different pages. Oh, and that's the, I think, Modbus address. Okay, and I can, yeah, I can increase it by 1 volt. Okay, and I guess if I press and hold, then it's going to exit the settings. Oh, I thought that we can have something for temperature as well. Oops. Factor reset, timing, screensaver, imbalance, over temperature settings. So that's 7. So let's check that again. Oh, 150 degrees. Okay, that's fine. Because I think I'm going to test with these. That's the easiest for me to create as a condition. I mean, not the 150 degrees, but I'm going to set it to like 30 degrees and I can just warm up with my hand. This is just a basic, I think, NTC element, and it's provided with a piece of lead. So I don't know whether it's intended to measure the device under load or whether it is, you know, supposed to be placed, let's say, in a cabinet, making sure that there is nothing overheats in the cabinet. But yeah, as you can see, yeah, the voltage, sorry, the temperature slowly rises. So that's cool. Okay, let me connect some loads. So phase A is a lamp. Phase B is a power station, which I think it's going to charge at 260 watts. And that's going to charge for, it's only 20 minutes, so we don't have a lot of time. And then phase 3, or C, is a fan, which, okay, I'm going to start this. Yeah. Oh, I was afraid that the consumption is going to be too low and it's not going to show, but you can see that we have, oh, how I can, oh, power factor. Yeah, it's measuring the power factor for each phase separately. So kilowatts, power factor. Okay, so we are drawing what, 5 watts here, 200 watts, and 12 watts here. Oh, and the timer started. I haven't noticed this one. Maybe I can review it, but I guess when I connected the first load, then the timer started. Okay, so I think we have got to the end of the document. Yeah, and it also talks about, and you know, it shows you how the TUI application looks like. and it looks like that there is a lot of different settings on the TUIP. You can see all the different details, and it draws you graph and everything based on the various phases and everything. So even the TUIA version looks very comprehensive. But let's take Modbus poll out, and actually I've already played with it, so this is already configured for this device. But let me show you. So connection, not disconnect. So connect is serial port, so that's so the default baud rate is 9600 baud, 8 bits, no parity, and then that's it. And the read is set up to read slave ID 1 and read the holding registers 10 at a time. And I'm going to pick unsigned. Actually, I think I'm going to put 100 and put 20 in a row. And I think we have pretty much everything on the screen. I might just go full screen. You don't have to see me for so much. Okay. And yeah, and the other thing I want to get out is this documentation, because that's the one that I was given. Actually, let me change the view, because I think it's going to be better. So this is the Modbus documentation, and maybe I'm just going to put this sort of like half screen. Where is the other half? Yeah. Sorry, I got into a flu yesterday, over the weekend. And so this is the, let me go full screen. So this is the document that I got, and it looks, I mean, sometimes it feels a little bit funny because again, everything was Chinese. So I just did like an auto translated and did correct it in some places where I thought it's going to be relevant. But before we do that, let me actually try to do something. So going back to the previous documentation, changing the Modbus address. I want to try this one first. Factory reset. That's page 14, the one which shows AS. So do I have the screen? That's not helpful. Okay, I don't think I have a screen layout where it shows this and the desktop as well. But so Modbus poll is running. As you can see, it's updating the values every second. So let me just go into the settings. What was it, 13? I'm trying not to touch the terminal, even those things are set. Oh, 14. Okay, so if I change it to 2, good. Now, yep, a response timed out because we have changed the Modbus address. Yep, that's it. So that's how you change the Modbus address on the screen. That's easy. And I think there was something in the documentation as well, how you change the Modbus address. So it says that the register 12 is the address and the baud, and the high byte is the baud rates, and the low byte is the communication address. So let's see, 12. So that's 770. Actually, let me change this to, I think I can do hex. Yeah, you see 02. So the low byte is 02 and the high byte is the baud rate. And, oh, sorry, I meant to use the other screen. So the high is the baud rate. Yeah, unfortunately, it doesn't really tell you what the you know, how these baud rates are translated into actual bauds. So maybe, you know, 01 is 2400, 02 is whatever, 03 is maybe 9600, and maybe 4 could be 11,000, you know, 15,200 or whatever. So anyway, that's so the documentation is missing in this part. But let me just try to do, just set it back so we can be sure. Oops, sorry, I meant to do this. 14, change it back to 1, save. Okay, back to this view, back to Modbus poll, change the address here. Yep, you can see the low byte is 01, so it's definitely the low byte. So at least that part of the documentation is correct. You know, the fan on the power station just kicked in. Fine, that's it. I'm going to clean up this document, but it's going to be fine for the time being. So this is actually a read and write, and I probably can write it as well. I don't want to write directly to it because I'm not really sure how I can change the address, the speed, but we have the screen to change the address anyway, so probably I think it's a good enough way to change it. Okay, looking further on, so phase 1, okay, let's go back to unsigned. So then we have the 3 voltages. So these are okay. So 13. Oh, we skipped 13. So 1600. Let's see if that gets changed, but I don't think it gets changed. And of course, we have no idea what's all these bytes are here. That's not documented. But again, they don't seem to be changing. Maybe we should keep an eye on these, but I don't think these are changing. So again, we can see the 3 voltages, and it looks like you have to divide it by 100, so it comes in 2 decimal places. So that's fine. So that's the 3 voltage ABC, and then the phase current. Yeah, so these are 2 bytes. And again, I'm reading the screen, so the phase on the first one is 30, or sometimes it's 31, yeah. And the phase and the second one is 0.819, or sorry, 826, so that's it. And then the 82, yeah. So these are the different phases, and you have to read 2 bytes, because I guess if it goes all the way up to 80 amps, that would be 80,000, which is more than, you know, 1 word. So that again makes sense. So these currents are okay. 23. There is always power. The high word is the third, the low word is the next register. Let me just do this. Okay, so there is always low power. So I'm just going to put question marks here. Stays at 0. I have no idea what that is. Okay, next one, phase A and B, C active power. And I'm guessing these would be, oh, what's the 2? Okay, 2 words. Okay, so these would be double words as well. Yeah, yeah. The numbers are changing every. Oh, okay. Wait. There is always power. So okay, that's actually these two as well, 23 and 24. So 2,300 and. I'm checking the screen, so I'm looking for something which is like 2000. And that's interesting. I thought it's a number which is going up, so it wouldn't be kilowatts. Oh, always power. I mean, that would be the total power. But that doesn't even add up because we have. Oh, no, it does. So we have. I turn off the lamp and that goes down. Yeah. So I figured this out. I think I figured this out. So you see the power figures. So basically now we have 183 plus 13 plus 6. And then probably some decimal places, and that would add up to, so that's basically 240 volts, 0.1 decimal. Okay. Total power across phase 1, let's see, more places. Okay, that makes sense. Okay, and then we have active power for phase 1, so that's 60 watts, 182 watts, and 6 watts, 184 watts, and then 13 watts. Okay, so that's the active power. Oh yeah, and it even shows you you have to divide it by 10 because it has 1 decimal places. You divide this by 1000 because it has 3 decimal places, 2 decimal places. Okay, actually the documentation makes sense once I understand it. And then total. So this would be, so this is total reactive power, and so that would be total active power. This must be it. And that's total reactive power, so that's starting at 31. So that would be, oh. So it's these two. Which is interesting, I don't know why it is, oh, the power bank. Oh, the power bank is doing some switching. Anyway, it's back at 180 watts. So yeah, I'm not really sure what this is. So setup. Let me change to signed. Okay, I mean that is, so we are at 31, so total reactive power, and then 33, so these two, and these two are going to be the reactive powers, and you have to read 2 registers and divide it by 10. I don't know why they are, I mean they look like they are negative numbers. Again, if I change, so that we have power factors 0.8, 0.8 and 0.7. So yeah, and this one looks like a positive number. This one is okay, and this is close to 0. I'm really not sure what's going on here. Maybe it's getting confused because I'm actually having the same phase hooked up to all the ABC inputs, which definitely it's not normal for a three-phase input. I give it a benefit of the doubt that that's the reason why this reactive power looks so stupid. But again, we have seen how it works for the active power. It seems to be working fine, so I'm assuming that the it's the same for the reactive power. And then we have total depends on the power. I can, maybe go back to the original Chinese translation. And this shows almost the same value as this. It shows 20 watts higher. And then what's this, what's that, and then this seems to be like lower than the powers here. I have no idea, but it says so it says volt amperes. Oh, okay. So so reactive power was already here. Not really sure. I have no idea what this is. Okay, moving on. 47, so that's 20, 40, 47 is the total power factor that needs to be divided by 1000. So that's 0.9, 0.8, 0.9, and 0.7. Yep. Okay, so these are the power factors. By the way, do I have... I mean, of course, I don't have the original document. I haven't saved it. Just one sec. Let me just check my emails if I still have the... Oh, let me see if I still have it in the downloads. Yep, I do. So this was the original document. So we are looking at what these two lines, 27. In case any of you read Chinese, I mean, I put this into translate. So data. I mean, I did the translate in. Maybe I should do it in Google. Okay. So Google Translate is much better than the Excel Translate. Good to know. Okay, we have gone through the power factors, so we understand those. And then we have 51 is frequency, so that's it's this one. Again, one single register. And then we have powers. Okay, so total power. And then we have each of the phases, and then you would divide it by 100. That again makes sense. So the total power is 11. And if you look at this, yeah, you can see it's 11. So that adds up. And then we have 60. So again, that's 20, that's 40. Oh, it says here 40, and then, okay, 60. Okay, that's 24, 23. That's the 23 degrees. The runtime. Videózok. Mi kell? Ja, elemek, vegye. Yes, yeah. So the runtime in minutes, sorry, that's 22, and yep, that's 22 minutes in minutes, and the alarm marker, so that's 62, that's empty. And that's the other really nice thing I like about these units. You have these markers which are basically bitmapped. So if it switches off the output, then you would be able to tell that it's switched off because of over voltage, under voltage, overcurrent, undercurrent, not undercurrent, but overpower, temperature, whatever. So we are going to test this. And then it says 63 is the meter status. So 0 and 1, and so that is obviously 1 because the unit is turned on. Hey, wait, no. Yeah, and so it's 1, and I'm going to push this button, so kill all the outputs. And then it turns to 0. So that's definitely working. And the other thing I wanted to say is that it says that it's read and write. So if that's 63. So functions, write a single coin. Oops, no, write a single register. So I want to slave ID 1, address 63, and then I want to write 1, and it says illegal function. So that makes no sense because so 63, I'm definitely writing the wrong, the correct registers, and I mean, write single register. There is no other way I would be able to do this, and it still doesn't allow me to do. So I don't think I've done anything wrong here. Why is it we are not able to change this? I mean, that would be the whole point, because let's say you know, you have some device that you want to measure or maybe protect using these protection circuits. So it switches off, you can tell that maybe it was overcurrent or the temperature or something. So you can decide what to do, wait, you know, close the valve, whatever, and then you can restart. So you should be able to turn this on again, which I'm going to do manually. And now it's on. So it's definitely working. It's the register that we want to change. I'm just not sure why it is not working. And if we go any further, so you see so we have the register from 64. So these are the things that we can you know, do. The protection values. And if you remember, over voltage was 275 volts, 81 volts was the under voltage, the overcurrent was 80 amps, and the overpower was 1.8 kilowatts. That would be divided by. So I can see all, voltage imbalance, everything is here. By the way, let's see if we can change this one. So write single register. So 60. Oh, I didn't know this function. So when you select this, it defaults the one which is selected. That's cool. Okay, so if I want to see 2760, illegal function. So none of these writes work. And I also notice this. Okay, let's do again the same thing in yips. Put it into Google. Only single word writing is allowed, which is fine. That's what I've been doing because I'm using the single register, write single register, not Modbus 16, which is to write multiple registers. Mask. Yeah, and I definitely want to use it. So it says only single word writing is allowed. I have no idea how to interpret it any different way. So and it's not a coil, and it's single register. So 64, the value, sleeve 1, and use function 6. Unfortunately, not even the Chinese version has anything in it which would suggest how you write this. I mean, I'm pretty sure that I need to write single register. So 276. Yep. So I'm pretty sure that I would need to write with 2760. But it's not accepted anyway. So functions, write single register. So can I turn it off? No, it's illegal functions. Yeah, again, the fan on the power station is kicking in again. Okay, screensaver countdown. Yeah, that's the 150, which is the temperature. So that's was 72. Yeah, that's the over temperature. So if I want to write this single register, let's say 140. It just feels like that there is something which prohibits any changes. Oh, it even shows the code on the screen, so that's nice. Again, I'm just checking if there is anything anything in here. No, nothing really. I thought there is maybe something in settings, but there's nothing in the settings that would just enable, disable, Modbus, whatever. And then 75. And I could possibly also clear the meters, which again would be important if you want to use the overpower. No, the over. Oh no, you can't. So anyway, no, the kilowatt. That's kilowatt. Okay, so you can't set a condition on the electricity, the energy used, and that was a little bit hard for me to understand. So let me just put this into Google as well. Okay, so I mean, my assumption is that you have to specifically write 5AA5 into that register in order to clear that, if you want to do that. But if it says illegal write, then there isn't much that we can do. Yeah, I can't really figure out how to write these registers. Maybe I should have taken a note if any of these were... okay, I'm going to review the recordings just to see if any of these values change. Maybe some of them are going to be some sort of counters, or maybe some enabler bits, but again, clearly nothing is documented. I try to find... yeah. I mean, I will see if I can get the website working again. Maybe I can get a contact. Maybe I will check once in a while to see if this website gets working. Oh, by the way, I did check, and they seem to do a lot of like more basic measurement equipment, like USB power measuring equipments. They don't have a lot of, you know, mains power. So this is probably one of the first model. Actually, there is also a single phase model available. So once I get this working, I might just buy a single phase model, because I think the inner working is going to be exactly the same. Obviously, some of the registers are going to be blank because it's only a single phase. But since this is not working, I mean, the settings are not, you know, making changes over Modbus is not working. Let me try something. So let me change the temperature. I wonder how low oh, okay, I can go all the way down. So let me go let me go 30. I'm pretty sure I can heat this up with my thumb. Okay, and according to the documentation, the over voltage, sorry, the over current, oops, over temperature is going to be 0.5. So the code is going to be 0.5. So here we should see this one changes to 5, this one changes to 0, and on the screen we should see 5 as well. So let me do this and just rub this sensor, just get the temperature up. Whoop, 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 hey, what? Come on, you can do more than 30. That's just stupid. Oh. Okay, that was a little bit. A and 07 is here. And so this has changed to, okay, this has changed to 0, and actually that's I realized it's binary. So binary encoding, so 32 2 to the power of, can I do power? 7. How I can do. Okay. It's not going to fool us. Which register are we looking at? Pip. Alarm register 62. So 62. Oh. I'm getting completely confused. Oh, so that's 62. Okay. So bit 1, 2, 3, 4, 5, 6. So I think the documentation is off. Oh, it says 5, which is fine because that's the 6th bit. So 0, 1, 2, 3, 4, 5. Okay, yep. And the 5th bit, which was the over current, the over temperature protection, is kicked in. So in decimal, if you're reading 32, then you know that's, I mean, I doubt that, I don't know, maybe there is a, I mean, it depends how these things are evaluated, whether 2 of the conditions can be met, like temperature and power and current or voltage something, then it is going to have, you know, multiple ones in these registers. But I think in other cases, it's probably going to be one that triggers the shutdown of this device. So I'm not sure, you know, that bit mapping is really required, but anyway, that's how the Chinese engineers designed this unit, and I'm completely fine with that. So yeah, so I think everything is working. I mean, I do like how it's designed and this mapping, but I just can't figure out why I cannot read these registers. And because without it, it's, you know, it's a bit useless. I mean, you can always go to the screen and, you know, do all these settings manually, but that's just not ideal. So yeah, so clearly I have a task ahead to figure this out, how I can get that one working. And it's not that there are any more registers in Modbus. I mean, it's, you know, 06, this is how you set registers. And clearly they mentioned that it's the same register that you should be able to read and write. So 06. Yeah. I mean, that's just writing multiple registers. That's, oops. That's writing coils. That's not what we need. Yeah, there is nothing really else. Nothing else. I've never used this function. So, I don't know. If you have any ideas, just let me know, because, you know, based on the documentation and, I mean, I have seen quite a few of these Modbus devices that came out from China, and they are definitely not overcomplicating things. So, I mean, the only other thing which I had in mind is that, you know, I wasn't sure in the beginning if these are holding registers or input registers, but I mean, clearly they are input registers. Oh, wait. Oh, but yeah, writing is the same. That's interesting. It doesn't even care whether you are, you know, using function 3 and 4. It still reads the same stuff. Wait. Let me do this unsigned. I used unsigned. I didn't think anything changed. Yeah, we have these weird values here for the apparent power. Voltages are same. That looks fine. And yeah, no change. It's still the same problem. Okay, I won't be getting any, you know, smarter by looking this any further. So I think I'm going to just leave it as it is for the time being. and try to get back on the email, and then maybe get hold of this, maybe do a little bit more Googling if I can find some email address. Maybe I will just try like info at, cofc.cn and see if I get any response. Maybe I'm just going to look through LinkedIn if I can find anyone with this company. I don't know. I don't think it's, it uses a lot in, LinkedIn is used a lot in China, but it's a nice unit. It would be really nice to get these last pieces of functionality working, because then it would be a great stuff. Okay, it doesn't cost a lot of money. Doesn't look like a really high-end and expensive device, but even if you have at home, you have a pump which costs a couple of $100, you can use this to protect it with another $20 device. Then it just makes sense. Even if you buy the cheapest version which doesn't have any Modbus, you just configure it for over current protection, and then it kicks in, and at least it's going to protect the motor or whatever device you have. So there is definitely potential. I do like the fact that everything is contained in. So even if you are integrating it to Tuya or Modbus with some sort of control system, if the internet breaks or if your control system breaks, everything is in there. So all the logic is there. It's like a self-contained thermostat. Once you set the the temperature, it's going to work even if you lose internet connection and stuff. It has all the logic inside. So and for that reason, I think it's definitely a good product, and I'm intended to get to the bottom of this, why this thing doesn't work. But yeah, I think it's been fun so far. It was interesting to look at, and once I figure out, there is going to be like a shorter video on this product on the channel, probably like condensed down into 10-15 minutes, where I'm going to just talk through the main things that I found, and probably going to clean up this Excel document as well, and then put all of these available for download, so you don't have to fight with these wholesale sellers who don't really understand this product. They just happen to have some documentation that they can send over, which in many of the cases is not there. I mean, I have received this documentation like 10 times, but this Excel only once from one single seller, so it wasn't easy. But anyway, it's here, so hopefully we can get to the bottom of this. But I guess that would be all for today. Thank you for sticking around, and look for the review if you are interested in the end result.